Hi everyone, this is a video tutorial 2.1 RGB LED. In this tutorial, I will teach you how to change the color and brightness of an RGB LED. We will be using two different potentiometers that will be used to change the color and brightness of our LED. A potentiometer acts as a resistor restricting a variable current flow. This effect will allow you to obtain different resistance levels and thus using it to gauge the color and brightness of our RGB LED. We will be talking about the basics of digital and analog input-output systems, serial monitor debugging, and scaling a range of numbers, which is called mapping. And of course, how RGB LEDs differ from normal LEDs and how potentiometers work. First, I will demonstrate how the knob potentiometer works. Then I will demonstrate how the membrane potentiometer works. So as you can see, as I turn this knob, I will get different brightness levels of the RGB LED. I turn it to one extreme, it goes all the way to full brightness, and as I turn it all the way to the other side, I get it very, very dim, and so that it turns off. So when it is off, this is providing 100% resistance. Therefore, there will be no current flow in the LED itself. And as I start to let current flow in, I start to turn the knob till I let a full amount of current flow, which is the other extreme of the knob. Now I will demonstrate how the membrane potentiometer works. As you can see, I'm providing no level of resistance to the potentiometer. Therefore, the LED is at full brightness. Now, depending on where I touch it, I'm just putting my finger here to hold it in place, I can change the level of brightness. As you can see, it starts to turn off the farther I get on the strip. So with this, you can use this strip to measure the location and as it resists the amount of brightness. So now I will go over how to wire this entire circuit, and first I will start off with wiring the LED. This right here is our RGB LED. RGB stands for red, green, and blue. So our RGB LED is different than a normal LED because it has three different inputs, red, green, and blue, compared to a normal LED which only has one and its specific color. So as you can see, there is only 2 pins on a normal LED, which is ground and power, while this one has 4. Each pin is being able to program red, green, and blue, and of course you have your ground pin. Your ground pin in this case, which is your longest pin. So now I'll show you how to wire it properly, and to wire it properly we're going to need 3 330 ohm resistors. This is important because we have to use the correct amount of resistance to require the most accurate color. So this is our breadboard. I'm going to install our RGB LED. There are 4 different pins, so I'm going to put it into 4 different lines in the middle of the breadboard. So in this case, it's going to be plugged into 5, 4, 3, and 2. See, just like that. We're just going to spread out like this so you can see the lines much better. There you go. So it is in 4 different pins, as you can see here. It is in pins A, 2, 3, 4, and 5. Now for each colored pin, RG and B, I'm going to install my 330 ohm resistor. So I'll plug them each over here just like this. As you can see, I'm putting the resistor across the board to provide current flow from this side to the board to here. This is because this side of the board is not connected to this side. So now as you can see, I have my 3 resistors plugged in to each of the R, G, and B pinholes. I branched the resistors from this side of the board to this side of the board so I can have more room to work with. Now I'm going to plug in a wire into the ground pin to the ground of the Arduino. So the ground pin is our 4th pin on our LED, and we're going to plug it into ground on this side of the board, which is grounded from the Arduino. So this will complete our current system for the LED. So now I'll plug in the corresponding wires into the RGB pins of the LED. In the program you will see later on, pins 9, 10, 11 will represent pins red, green, and blue. As you can see, I color-coded all 3 wires over here. So I'm going to plug in red into my first pin. Just like that. Sorry, my ground wire is in the way. Actually, I'm going to take out the ground wire so you can see better. So I'm going to plug in red into my first resistance pin, just like that. And then I'm going to plug in green. And now I'm going to plug in blue. I'm going to put back my ground. Now if everything's correct, I'm going to plug it in. Yours, however, might not light up the first time because there's no program telling these pins what to do. So since my program is already pre-installed, my LED is going to light up. So as you can see, all the LEDs are on at this time. So it is a very bright whitish color. But if you look really closely, you can see that there's you can see the 2, 3 LEDs lighting up here. I can mainly just see blue and green right now. But as you can see, if I start to unplug these two, if I start to unplug blue and green, I'll be left over with red. I'm going to turn that up so you guys can see it better. So I'm left over with red. If I unplug red, I will have no colors. So if I plug in my green pin, I will have green. If I plug in my blue, I will have a mix of blue and green, which is a very bright turquoise. And if I unplug my green, I will have just the blue. Now if I plug back all 3 of these, basically it should be a bright whitish color. For demonstration purposes, I'm going to plug in a 10K ohm resistor into my blue RGB LED pin. So initially we saw the color blue with the 330 ohm resistor. That is a very bright blue. So now if I switch out the resistors with my 10K resistor, you can see it is a different type of blue. If I put it back, we'll obtain the correct color of blue. This is important if you want to get accurate results. So now I'll show you how to wire the potentiometers. So to wire the potentiometers accordingly, there's 3 pins on the potentiometer. For both potentiometers, it is the same. Let's put this one here. So for both potentiometers, it is the same. They both have 3 pins. One stands for ground, power, and our programmable pin. I like to use the color yellow for programmable pins. So first, I'm going to wire it with the knob potentiometer. So the 3 pins are going to be placed into 3 different pinholes. I'm doing the same effect that I did over here with the RGB LED by putting it on this side of the board and connecting the wires over to this side. And again, this is so that I save a lot of space. So first off, I'm going to start off with the two outer pins. The two outer pins represent ground and voltage. So I'm going to use my white wire for ground. I'm going to plug it into the most outer line, which is my negative line. So now I'm going to take my red wire, plug it into my positive. So now I have a complete circuit flowing through the potentiometer. Now I'm going to take my programmable wire, which is going to be my yellow wire, and I'll plug it into A0, which stands for N-log0 pin on my Arduino board. And I'm going to take the other end and plug it into the middle of the potentiometer. So now, as you can see, as I plug it in, my potentiometer works. So now again, yours won't work just yet, but we're going to go through the programming. So once we have everything wired and set up correctly, now I'm going to go through how the program is going to look like in our code. So first off, I'm going to start off with some variable initialization. So as I stated before, we're going to have our red, green, and blue pins into our pins 9, 10, 11. So I'm going to write in constant integer red underscore pin equals 9, constant int green underscore pin equals 10, constant in blue underscore pin equals 11. So as you can see, my red, green, and blue pin each correspond the following pinholes, 9, 10, and 11. So I'm also going to call which pinhole I plugged in the potentiometer. And if you guys remember, it was pin N-log0. So I can easily type in constant int pot underscore pin, I don't know why I keep typing plus, equals 0. So I'm also going to call in another integer which will basically store our values that will be read from our potentiometer. Type in int value, and we're going to initialize it to 0. Once we have everything initialized properly, we're going to go into the setup and call what to do with our RGB pins. So we're going to write pin mode red underscore pin output, and we're going to do the same for green and blue. Green underscore pin output, pin mode blue underscore pin output. This is basically saying these three pins, pin 9, 10, 11, are going to be writing towards. We're going to be given those pins a set of value, which you will see later on. So after our setup, before we write our loop function, we're going to write our digital output and call it inside the loop function. So we're just going to go under our void loop and type in void digital color, or digital colors, doesn't matter. Open and close our brackets to start this function. And we're going to write digital write brackets red underscore pin value, digital write green underscore pin value. Lastly, digital write blue underscore pin value. So with this is saying that we're going to take each pin and assign it our value. So with that in mind, remember our value is going to be changed by our potentiometer. Depending on how we turn or press down on the potentiometer, our value number is going to change. So we're going to call this in our void loop, digital underscore colors. Okay, so now I'm going to show you what digital versus analog means. So since my function is digital write, I can only write two different values that will be written towards each pin. Each pin will either be on or off. So with that in mind, on or off is also represented as 0 volts and 5 volts at its maximum. So in our potentiometer, we can state an n-log value, right? 0 to 1023. However, since we're only writing digital values, we can only write 0 as 0, and any number greater than that will be represented as 1. When it's represented as 1, it will be on. Before we start uploading it to the board, I forgot to set the value of our potentiometer. So to do that, I'm going to type in value equals analog read pot underscore pin. So that right there is going to get analog values from our potentiometer. To actually view what numbers I'm getting, we're going to start the serial monitor. The serial monitor is basically your console. So we're going to basically print what numbers we're obtaining. So first we're going to add the library. So we're going to hashtag include brackets software serial.h. And in our setup, we're going to initialize the speed at which it's going to read. So we're going to write in serial.begin 9600. And then down here in our digital colors loop, we're going to print out our value. So to do that, we're going to type in serial.print. Let's leave a space. This is just basic white space. And then serial.print ln for line value. This is so that we can show what numbers we're obtaining from the potentiometer. Now let's upload the code. As you can see, the lights were flashing over here. That means we're transmitting the data through our USB port. Right? So as you can see, my LED is off because of my potentiometer is all the way off over here. So you see as I turn it immediately and it turns all the way on. And sometimes it doesn't even read that my potentiometer is all the way down to 0. So I'm going to show you what the serial plotter does. The serial plotter basically plots out our values on a graph. So if I run the serial monitor, I'm just going to change the baud speed to 9600 because that's the speed at which we're reading it. As you can see, it's clearly at 0. This is just a graph of our values over time. So since everything's at 0, that means our LED is off. Right? So that means no voltage is being currently written to our LED. And then as we turn it on, we immediately jump up. Right? So you see it immediately jump up to 150 and so on, right? But depending on the potentiometer's value, this LED is always going to be the same level of brightness. The LED is going to be the same level of brightness. It's because it is digital, as I mentioned before. Since it is digital,
we're only going to be receiving numbers between 0 and 1, and 0 representing 0, and 1 representing 1 to 1023. As you can see on the graph, I have my potentiometer maxed out at 1023. 1023 is represented as 1, just like any number in between. As you can see, I can almost get 0 going back, but not quite. Not quite exactly 0. Now I'm going to show you how analog values work with our potentiometer. So now how analog values work is a bit different than digital. As I stated before, digital values are only values between 0 and 1. Now, that means this number over here, any of these numbers over here is either written as 0, or say it as off, or 1 as on. Correct? Now, we want to change the level of brightness. We want those numbers in between 0 and 1. So to obtain these numbers, we're going to write it as analog values. This is because we're able to control the amount of resistance in between. With that, we can control the amount of voltage being provided to the LED. So I'm going to type in void analog colors. This is going to be a new function. Very bottom. I'm going to take the same value. That value equals analog read pot pen, and then I'm going to write in analog write red underscore pin value, and then analog write green underscore pin value, analog write blue underscore pin value. So now my numbers are not going to be digital. My numbers are now going to be analog. So since we are obtaining numbers 0 to 1023, our LEDs are measured in hex value colors, which is 0 to 255. So we're going to scale our number range from our potentiometer to 0 to 255. So there's an easy way to do this without doing all the division and multiplication to scale numbers down. So for example, think of it as going from meters to miles per se, right? It's basically converting it into two different ranges. So I'm going to change my value number and use the map function. Use the map function. This will scale my original values from 0 to 1023 to 0 to 255. So now I will only obtain numbers between 0 and 255. And since I'm writing analog values, not digital, I can obtain all numbers in between 0 to 255. So I'm also going to print this again, just like I did with the digital functions. I press Command or Control T to properly indent all of my functions. So instead of writing the digital colors function, I'm going to double slash to comment it out. I'm going to just run my analog function. Analog underscore colors. Then we go ahead and verify. Oops, I forgot colon down here. So I'm going to go ahead and verify. So now it's verified. I'm going to upload the code. Again, you should see it running through the steps, reading 100%, and then it should be done and say done uploading. So now that it's done uploading, so I'm going to go launch my serial plotter. There we go, it starts writing. Now that it's stuck at 0, my LED is off, of course, once again. And now I could obtain levels of brightness in between. So you can see there's a bit of variance that makes it jump up and down just very slightly. That's just the nature of the potentiometers. It's just a hardware issue. There's different types of filters you can make to average out a medium value so that you can obtain a closer value or more accurate value each time. So as you can see, as I start to increase it, the brighter it's going to get. Right? The brighter I'm going to make it up here, and then as I go up all the way, it's at max brightness. Remember before, as we printed out the value, the max number was 1023, and over here on our graph, it's sitting between 150 and 300. This is 255, just over here. 255 is our max value here, since we scaled it. We used that mapping function to scale 0 to 1023 to 0 to 255. I'll just show you a quick demonstration of it going down once again. So you can see it goes down all the way back to 0. So see it turns off, and then it narrows that to 0 on the graph. And my LED is off. Turn on again. It starts to go up, then down. So this is just one simple application you can use for a potentiometer, basically just changing the values of an LED. To further expand on this, you can also use this type of code to change the position or angles of a servo motor for a robot. Basically, you can use the knobs to control it, or even use the membrane potentiometer to change the position and location of it. This concludes lesson 2.1, RGB LED. If there's any more concern, or if you further want to expand on this, please read the 2.1 RGB LED lessons, and also this code will also be online. Thank you for listening, and have a great day.